Um, I'll do a quick intro. Hey everyone, so today we have Alpha again. You already know who he is, don't have to do much of an introduction. But today we're going to be doing a coding interview, lead code base, and he's just going to do it in Java. So, yeah, Alpha, want to just say why you're doing this stuff in Java?
Yeah, so I just wanted to learn like a static compiled language. Because I already know TypeScript, I feel like knowing like Python or something, I can easily just go to that if I need to. It takes me like 5 minutes. So I was trying to learn something completely different, I guess. Just so I can like have that knowledge. Also, yeah, I guess in the future if I want to like do more, back end or infra or that type of stuff. Yeah, like some companies are interested in that kind of stuff, and yeah, I feel like I can kind of have all my bases covered then. Because if they want Python, I do like TypeScript, JavaScript. It's like the same thing. And then if they want some
Yeah,
compiled thing, then I have that as well.
yeah, that makes sense. And yeah, I'm just going to hop straight into the question then. We're going to try to do two questions,
All right.
and let's see how fast you can do it. If we still have time, maybe we'll do a third. I don't know.
All right.
All depends on what you're trying to do.
Yeah, I might have to ask the AI assistant for what's it called
Yeah, go ahead, Dick.
syntax.
This is life these days.
It's life these days. Okay,
So,
okay. Peak element is an element that's strictly greater than its neighbors. Find a peak element. All right, all right. Runs an n log n or log n. Okay. All right. So there's one. It can be one number. Okay.
yeah, so we're just trying to find any peak element in an array of numbers, and a peak element is a number that's greater than its neighbors. So three here is a peak element. It's actually
Right.
the only peak element here.
Yeah.
But
So I
pretend
think.
there was the boundaries are negative infinity. So even if we have five here, five is actually a peak element, and we could actually return five too. There's multiple answers. We just need to return any of them.
Right.
But the main constraint, like you could just assume the bounds are negative infinity.
Right.
And the main constraint is that we just want to do this in log of n time.
Right. So yeah. So I'm just gonna handle like here. I'll write down kind of quickly what I'll do. So I'll just handle like the just to make the code easier. The like one number or the ends are a peak and like some checks. And so if that's the case, I'll just return those. So if it's one number, it'll always be a peak. If the end is a peak, I can just check for that quickly. And then after that, so I think there's guaranteed to be a peak. Like you can't have not a peak if numbers are different. So yeah, guaranteed peak. And then it's just going to be like a binary search of like if my number is greater than both, return that. Or what are we returning here? Index. If it's we can compare it to like the left and the right. So if it's like greater than the left, then you can kind of picture it like a mountain. So like a
And
mountain
there's
with
a
no.
drawing order. You can hit this drawing mode too if you wanna.
Oh yeah, let me do that. Castle Ridge. Okay, yeah. So basically, like, so it's gonna look one of three things. It's either gonna be a peak, or it's gonna be here, or it's gonna be here. And so I can just compare it to the element like to its left. So if it's like bigger than the element to its left, then it's on this side, which means I need to binary search this way. And if it's smaller than the element to its left, that means the peak is on this side, so I binary search the other way. So I just yeah, basically that's all I would need to do then.
What if you're just on like this case or this case?
You're a little bit. Let me zoom out or something. Wait, how do
I'm
I?
on the side here. Oh, you don't see here?
No, I'm trying
You
to.
drawing?
I got it. I got it. Okay, so what am I? What am I at? Draw one more time.
So okay, what if you have just a slope like this? That's the input of numbers. It's increasing.
Yeah, so if this is the numbers, then I'm just gonna do checks in the beginning, and I'll just return that because that's the end. So I'm gonna check the ends in the beginning. So then, if it's not in the ends, it has to be in the middle, and then you can't have this case. So it
You
has to
can't have
be
this
like
case.
this. No, because if it's like strictly increasing, I'm just gonna check if the last number is bigger than the second to last number, and if it is, then that's a peak, and I'm done. Right? Does that make sense? Like if I have like 1, 3, 5, 7, I'm just gonna check the ends in the beginning. So like if this is bigger than this, then this is a peak, and then I'm done. And same thing here. If this is
Okay.
bigger than this, and this is a peak, and I'm done. So it has to be like a mountain.
Yeah. Yeah, that makes sense. I feel like we can have the algorithm though just general and not have to check that case.
I
Like what
could, but
happens
I'm
if
gonna
we
be
make a
comparing
middle here?
numbers to like their neighbors, and I don't want to get like out of bounds. So
I
like,
see.
so I'm only gonna compare the inside part. So that's why I'm gonna do the check for the outside ones first. I mean, yeah, you could probably do it all in one, but it's gonna be like just saving me a lot of time to do the checks ahead of time, and it's not gonna like make it slower or anything.
Okay, go ahead and implement it then.
Okay. So I'll just write this function. So let's actually add the tests first.
Test-driven development.
Yeah, I was trying this. It actually works surprisingly well. So I'm just gonna write the test first, and then I can run it, and then like, yeah, it works very well to be honest. Okay, so we'll try like what was it called? This like find peak or something. Um, and so we'll try it on just like one number, and it should just return that number. And then we'll try it on a couple more. So we'll try it on this one. Then we'll try it on this one. Okay. And then we'll try it on a sorted array as well. So, like this. All right. Yeah, so now I'm just gonna make this peak. It's gonna take a int array nums. So yeah, I'm gonna check for those things that I said. Okay, yeah. So if and I'm gonna assume I think the constraints it had one or more. So if nums length equals 1, then we can just return that guy. And then we're going to check for the two ends. So if num0 is greater than nums1, return num0. So that's the left end. Same thing for the right end. And then the other one. It's 2. So return that one. All right. So now all we have to do is check all the numbers between those so they can't be the end, and it's guaranteed to be a mountain now. So it's going to be a lot easier. So we can just say like int left equals 1, right equals nums length minus 2. And then just do a binary search. P. So I think in Java you have to do it this way because you might get overflow depending on constraints.
I usually just do it that way, even in Python.
Yeah, I mean you can just always do it this way. I feel like it's just a little bit less intuitive than like the half one. So, but yeah, you can do it in this way in every language. Yeah. And then
In Java, how does it handle divisions if the division has is a float?
yeah, so it's
Pretend
really
it does
nice
add.
actually. So if it's an int, it will make everything an int. So it's very convenient. So like this will just be floor divide.
But
If
it
it was
takes
a
the
float,
floor.
what was that?
It takes the floor.
It takes the floor, yeah, because like the left is an int, the right is an int, so it takes the floor. If one is a double, then it will do a normal divide with no floor. Yeah, so it's actually very convenient, I think. Okay, so if nums pivot is greater than the nums pivot minus 1, and nums pivot is greater than nums pivot plus 1. And I think one of the constraints was two numbers can't be the same, so this is the answer then. This is actually wrong, by the way, looking back. So this needs to be 0, 0, and then, because I think they want the index. All right, so then we have two more cases. So if nums pivot is greater than nems pivot -1. That means we're like going up the mountain, so it has to be on the right. And then we can have an else. And I think in Java you need a what's it called? A default return, so we can just have this. Okay, so let's give that a go. See if I messed up any syntax. All right, so 0, so that's correct. 4, yeah, it should be the biggest. -1, so that's not correct. So it should be, yeah, definitely not -1 there. Okay, so for the ones that, for the binary search one is not correct, so let's double check why. Oh, it has to be this way, right? Okay, 1, 2, 3, 4, 5. Yeah, okay, it's good now. Yeah. Yes, I do find this, like, writing the test ahead of time actually is very useful. Because you know exactly what broke very
Yeah.
quickly. So I started doing that.
Nice.
Obviously, with LeetCode, it'll give you stuff, but if you don't give me anything, I found it quite good.
Okay, solved it. Quick. Holy. Let's ask it. Yeah, let me find you another one. Give me a second, let me pause.
Okay.
Are you using ChatGPT, Paul said, or Interview Coder?
Am I using Chat? Yeah, I'm using ChatGPT. I mean, this is
I
like for a problem like this is the same as this is literally the same as Python, right? There's like no Java difficulty in here, so yeah.
Yeah. Let me find one. Dude, like, I
I
don't
mean, I've
know.
done a lot of problems, so I don't
You
need to
solve
use it.
problems so fast. We have to ask four just to fill up.
Yeah. Hey man, I'd rather do 4 than some crazy hard one that I gotta think for an hour, so it's fine. This is like the meta type interview, right? They just give you mediums, so that's the goal: be
Yeah.
able to do it fast in Java. I actually want to.
Okay. This one's sort of a classic one, but it's important to just make sure you have good recursion, like you're able to handle recursion
Okay.
in Java. But
LCA.
it's the prompt.
Okay. Okay. Cool.
And, like I have extensions if needed.
All right. All right. I mean, yeah, obviously did this one before, but so with this, so there's a bunch of ways to do it. One is you can like make paths, and then you can like compare paths. The better way is let me go to the drawing again.
Here, let's just explain the question first for the viewers. So
Okay, sure.
I'll just write out the example so
Sounds
I have
good.
one on LeetCode. So I mean we're given 3, 2, 1, 6.
Oh, where are you writing, by the way?
Oh, you don't see?
In the drawing
I'm
or
I'm in the drawing.
Oh,
Yeah, I'm
okay,
in the
got it.
drawing. You didn't see it?
Okay, yeah. No, yeah. Okay, cool.
So
Got it.
we're gonna be given two nodes. Pretend we're given two nodes. We're gonna be given a P and Q. P and
Mm-hmm.
Q. If we pick 6 and 2 here, the greatest common ancestor is. Oh, this needs to be
So I believe
different.
they should all be like unique or something.
Distinct, right? Yeah.
Yeah,
Just
and
a
then I
little
also believe
bit.
that they are always present in the tree for this one.
Yep, yep.
Okay.
So 6 and 2 here. We should return. This is the greatest common or the lowest common ancestor. 3 is an ancestor, but 7 is the one lowest in the tree. Pretend we put 6 and 1 here. What that means is if we did 6 and 1, the lowest common ancestor is 3. So we essentially just need to return the lowest common ancestor between two nodes. It's a classic one, but it might be difficult in Java, and I'm gonna extend it.
Sure. Yeah, so as I was saying, so the optimal for this, I think there's something even more optimal, but like the reasonably optimal is you basically like go down until you see a node and then you return values when you see the node. So you return like how many nodes you've seen that match P and Q. So what that would look like is like you would use any kind of DFS and then you would basically
Are you in
return.
drawing?
Not yet. I'm just explaining, but I'm gonna draw it right now. So like for this node, you would just return one because we've seen like one node that matches P or Q. Here we'd return 0, and then at 7 we'd return like the total of what we've seen, so it'd be 1 again. And then here we'd return 1, and then when we go back here, we're gonna get a 2. And like the first place we hit a 2 is the lowest common ancestor, and so we can just mark that as the node. That's the answer. And then after that, we can just like reset this number. So from here, we can just return like 0. So there's only going to be one node that we're going to head it to. And yeah, basically once we hit a 2, we'll just set our whatever variable to that node, and that's going to be our answer. So let's say if this wasn't 6 and 1, if this was 6 and 2, this would return 1, this would return 1. You'd get a 2 here. So you'd set this node as the answer, and then you'd return 0 up here. 0, 0. So once again, you're only going to hit a 2 in one node. Does
Yeah.
that make sense?
Yes, that makes sense. And what's it called? So what kind of like DFS is it gonna be? What variant?
It doesn't matter. Just any kind of DFS, like left or like in order would be fine. Or I no, actually, you just need any DFS where you visit the children before you check your current node. So I guess that's technically post order. But you can go like right then left or left then right, doesn't really matter. So I guess it would be post order. Uh, yeah.
I mean, if you if you did with it in order, would it be possible?
No, I don't think so. Because you have to
Because you
visit
need
you
to
have to
know.
visit the route last. Yeah.
Okay, go ahead and implement.
Okay, yeah. This one's going to be a little bit more annoying to write tests for. Uh do we have a Yeah, do we have like a tree node, or do you
We
want me
can
to make that as well?
make the tree node.
Okay.
Yeah, just make the tree node.
All right, so we'll make tree node. And I'm just going to make one that can only have like int values for this case. I'm not going to make like a generic one or anything. So the tree node needs to have a couple things. It needs to have an int. And do I need to worry about making like the value private and all that stuff, or does it not matter?
Yeah, I'll just make it private just because.
Okay, so I can make it private, and then I would need to make setter or getters, I guess, to actually access the values. So it would be like private int val, and then the pointers as well. Okay, so we'd make like a private tree node left, and then private tree node right. And we just need a constructor. I guess these can also actually be final because they never change. So then we just have a tree node and constructor. It will take a int val, tree node left, tree node right, and then I guess this should be public. I mean, it doesn't really matter because it's going to be in the same class as this. So, but yeah, okay. So this left field may not have been initialized. Okay, yeah, let's see what happens to make it. So this val equals val. This left equals left. This right equals right. Let's see if I have any. Okay, there, we're good there. Okay, now we just need getters for all these things. So public, what is this? Int get val, return val, then public tree node get left, return left, and same for the right.
In Java, there's no way to specify optional, right?
So actually, they can all be null. I think there is an optional, but this can be null, and it will give you null, so it'd still be fine. So I can declare this thing with like null. I think there is a way to actually do optional though, to like make it more clear. I think there is some stuff. I just am not super familiar with how it works. But yeah, these can be it says it's a tree node return, but any object can also be null. So it's like a tree node or null essentially.
Yeah, because none is an object, right?
Yeah. So it works. Yeah. But there's a way to make it more clear where you give it like optional to let the person know like this is pretty likely to be
I
null.
see.
Yeah. Okay. So let me get rid of this and just use the solution guy. Get rid of this. So let's make. Yeah, we'll worry about tests afterwards for this one. I feel like because it's going to be a little bit more difficult because there's trees. So we're gonna make a static class called get LCA or something, and it's gonna take a tree node root and then a int p int q or something. And yeah, I'm just gonna make these static because they're like in our main thing, so we like don't want to initialize their solution. And I think this returns an int. We're returning like the int, right, where they intersect. I believe
Yeah.
that was the problem. Okay. Yeah. So from here, we need to make a helper function that's going to be also static. DFS tree node node int p int q, and then we need
Actually, we're
some
gonna return the actual node.
uh we're not going to return the actual node. We're going to return or we're not going to do it. We can return the actual node. Like, what do you want to do? Do you want to return the actual
Yeah,
node?
we want to return the actual node.
Okay.
Yeah, that should be tree node.
Okay, in that case, so what I'm going to do then is I actually need a setter. Uh yeah, I need a setter then, and this is not going to be. Can I create it? I guess I can.
What's the setter for?
So I need to, in my DFS, I need some way to set like my node to what I found. Like I can't just return because I'm yeah, I can't return the node here. So this is actually going to return an int. I can't return the node because I need the ints to figure out like where I have that thing. So I think what I need to do.
Well, here we're gonna be, these should be type tree node.
Oh, they
Or
should be.
wait, let's see.
Well, even then, it wouldn't really matter. I don't think these are type tree node. I think they're.
Like on the LeetCode, it is.
Oh, interesting. Okay.
Yeah.
Okay. Yeah. I mean that doesn't matter. So I still need to like this can't return a tree node. This will return an int, but I need to somehow in here. Um. I need somehow in here to set a tree node that I create in here. So I think I can do like this tree node res or something, and then I can just make it here, and then I can just pass it down, and then I can set it equal to something else later. I think that'll work. Let's see what happens though. Okay, so what we're gonna do in this DFS is we're basically gonna say like if node equals null, and we can just return 0 because there are no like matches. Okay, now we need the total of like how many matches are there. So if node value equals okay, yeah, so I could just pass down these values, that's fine. So p or node value equals q. We're gonna increment the total. I think I need to do like a get, right? Because it's private. Okay. Okay, now I need to calculate the left side. So DFS node, I think get left, PQ, DFS node get right, PQ. Okay, so if, or then I can add that to the total. So if this is 2, that means this is my node. So I need to actually pass a tree. Yeah, I don't know if this will work. I know how to make it work for sure, but I'm curious what this is going to do. So what if we do this? So if we say this, then, yeah, so if total equals 2, so we need to set tree node equal to this node. X equals, I don't know if this will work, but we'll see. But I know how to make it work for sure.
I think X is a local variable, so it's just overriding what's in that
Well,
local variable, I
I
think.
don't think it's a local variable because I think it's like an instantiated object. I mean, I guess I could do like a hack, or I could make it like a class variable. Like what I could do is
Or
I could, yeah, but let's
so
see. Or go ahead, sorry.
how do you return tuples in Java? Give me that
Uh,
too.
how do you return tuples of different types is going to be kind of a pain.
Like pair? Like have you used pair Java?
Yeah, I honestly I think the easiest way to do it is honestly this. Like I just make something that's not local and then I can just pass that down. And then this will work for sure.
That one would work, yeah.
Yeah, so
Because
I
now
just
it's
make it like
it's
this.
res and then you would just add.
Yeah, exactly.
But, okay, let's try the other one. You thought it would work if we just do the X equals that or res?
Yeah, let's try this. So I know this will work for sure, so there's no need to test that. But let's try the other way, yeah. So tree node, uh, like res. Yeah. So I can make it a new tree node for now because it's going to get overridden anyway. So I can just make it like 0, null, null or something. And let's see what happens if I pass it down or if it complains or anything. I can also,
But
yeah,
that's just like
this is where I'd ask
kind of the
like
same
this is where I'd
of
ask
like
the AI thing as well. Like, how do I make this thing like update?
yeah, ask it. Because I feel like it's just like the same as overriding it.
Mm-hmm.
Very- You can ask it, throw it in the AI assist. Yeah.
Well,
Does that work?
let me do the rest of it
Oh
first.
yeah, try, yeah. Yeah.
So why is it complaining here? Method in the type solution is not applicable. Oh, because I need to pass down the x. Okay. Yeah, I'll ask it at the end. So if total equals 2, then x equals this node. So that's just node. And then I just don't want it to ever be 2 again, so I can just return like 0 or something. And then otherwise, I just return the total here. Okay. So, yeah. So I think this will be fine. And then, yeah, I can just do DFS of root, and then p dot get val, q dot get val, and res, and then return res. Okay, so now we need to actually make this tree and test. So let's see. Okay, so
Just make a very small one too. Like
yeah,
just
maybe let's try like just a tree with two nodes or 3 nodes or something.
yeah.
Or let's try a tree with two nodes. Yeah, so and var cur equals tree node. Okay, so literally it'll just have like 0. Let's see. Yeah, I think for the sake of testing, can I just change these tree nodes to ints because then it'll be easier. Like I know it'll be exactly the same thing. There's kind of nothing to be gained here.
Well, I'm gonna ask a follow-up question this
Okay, cool. Okay, cool. So in that case, let me do. Okay, so here I'll just make like a new tree node here, with value like 5, and then null null, and then this is null. Okay, and then I will want to say like tree node or var p equals new tree node. So this value needs to be 0, null null, and then var q new tree node. What's the other one? 5. Okay, and then we can go. Or whoops, we just do this. Whoops, not that.
Well, we want to compare by reference, or I guess it doesn't really matter. Because
Yeah, I mean
they're
they're all
right now.
different, so it's yeah, it's not gonna matter. Um, or I guess we could do, yeah, we could do by reference, I guess, if you want to. So here we should basically get cur, I think in this case. So we want to say like get LCA of cur PQ. So to compare by reference, I think you just do a get equals cur. This method is undefined. Did I misspelled it? Okay. So let's see what this gets. I'm going to have to debug further. False. Okay, so instead of this, let's do val or get val just to see like if we're even getting anything. Okay, we're getting 0. So that's this initial value. So let's just make this like this so we know if something happened. Okay. And let's also do a print here. Oops. Just to make sure we're actually doing something here. Looks like we're not. Okay. Yeah, looks like we're not. Because we're basically printing, let's see. We're printing here. And, or are we doing something? No, we are, right? Because it just have the -1. So I think that is correct. Yeah, okay. So we are getting to this, and this is node 0, which should be the answer. But then this x equals node is not working. So basically,
Like
yeah.
once it leaves here, it goes back right, to or what's
Yeah,
the
yeah.
the
But
res here is not changing just because you passed it in here.
yeah.
Like
Yeah,
if
so
if you did the same print after, it's gonna go from like -1 to 0, right? Maybe like you print it out here, it's
oh,
gonna
like res get val or something?
yeah, it's gonna go back to -1 there.
Yeah, yeah,
It's just gonna
that's
print
what I'm
0.
saying. Yeah, I'm saying this isn't working. Yeah, like what I was saying isn't working for sure. Yeah, I I definitely know that like if I just updated its value, it would work, right? Like if I passed it here and I just said x val equals this, but then it wouldn't
Yeah.
be the same by reference, right? It would just be the same value. Yeah, so I think so. Let me think what's going on. Oh, because I guess it's just making like the low. Well, yeah, it's. I mean, you never really do these things where like you pass an array and then you just like modify the array to a new array. So I don't know how that works exactly, but yeah, that makes sense that it's not working. So I guess yeah, the alternative is just make an array here, right? Make an empty array and then just add to the array, and that works for sure because you're not changing the reference. You're not changing the address. Where I think this changes the address. Yeah, so
See.
I think, do you want to go with that approach then? So instead of this tree node res, we just make an array.
Like what I think that one's okay too. Just also hacky. Because in Python we'd probably do this, right? We just return a node.
Yeah, yeah, yeah. That no,
Like
yeah, for sure.
you can do this too in Java. I've interviewed candidates and they did this in Java using the pair API. So they defined that we're gonna have a pair that returns an int and the tree node.
Uh huh.
So maybe
So maybe
try
look
doing
up.
that.
I guess
Yeah,
I could
look it up on the AI
look up
system.
how to do that
Look
with
up
the AI
pair.
thing.
Yeah, yeah.
Okay, yeah. Let me do that. So let me go back.
Because you'll have to do this a lot. I've seen like most candidates they pull out pair.
No, I'm definitely. Wait, what happened here? So this was. I think. Oh, it's because you were typing in. Okay, I see. So. Okay, so here I need to. Yeah, I need to return a pair. So I need to change this thing. So here, yeah, I would just say like x equals node, but this doesn't work. Okay, yeah, let me do that. So in this function, or I guess, yeah, let me just, do I have to copy my code or something? Let me see. Okay, so,
Ask or just ask like how to use pair. Like don't copy and paste the whole thing.
oh yeah, yeah.
Ask how to use pair, then augment it.
How can I use
How to use pair,
pair
yeah.
to return a value and a tree node together in my DFS so I don't have to pass this node down? Okay, yeah. No, it definitely works. Let's see. So where's the pair? Is it just like an
Got
import?
C++? Oh
Oh yeah. I don't know how that
my
happened.
god.
Give me this in Java instead. Yeah, that was weird. Okay, so let's read it. So pair, you can implement pair-like structure. In Java, we don't have a built-in. Okay, well, if it doesn't have a built-in, that's going to be annoying.
Like, okay, how do you ask it? How do you do tuples? How do you just return simple tuples? I'm just curious.
I mean, you can definitely make a class, so that would work for sure. Custom class, abstract. Yeah, I'm not familiar with this. I could have sworn there was a pair, like an actual. Yeah,
Maybe
so I
they
could.
removed
So you
it.
could do this. I'm gonna look that up
Simple
later.
tuple.
Yeah, so you could. I could like make a class, but I feel like that's gonna take a while. Yeah, so maybe this is something I can like research in my own time, I guess.
Okay, there's map entry. There's an entry integer node.
Where's that? Where are you seeing
Here, I'll point the very last piece.
that? Okay.
Cool. See, this is the stuff that makes Java annoying on it.
Oh, wait, where'd you
You
write?
can
Oh,
see
this?
up here 21 to 20.
Uh
So we
huh.
return an empty tree node. And from there,
Okay,
see that?
public map entry. Oh, I see. It literally makes a new abstract map. That's weird. Yeah. So this is like a key value pair in a map. I mean, this is also kind of hacky, so I don't know if this is better, but sure, let's try it. Okay, so integer tree node. So how do you make the entry here? This, I guess. Okay. So this needs to be 0 and like null then. Okay. Then I need to read it. Okay. So left result. Yeah, I feel like this is only difficult if you like go down this approach, which I wouldn't do. Okay, so this is right. Okay, and this is like, how do I access the actual things here? Get key. Oh wow, this is very hacky. Yeah, so this is basically like you're making a key value pair where your key is like the left return and your right is your right return. So this is like I would argue, like I said, more hacky than the
Okay, in
other one.
Java they got rid of it.
Interesting.
What did they do? How do you
Okay, so in that case, we would return this. Yeah, like I would honestly argue that array is better here. Okay,
Yeah.
0 and add no, what's it called? Node, and then here.
Yeah, like there's multiple different ways. Back when the pair was around,
I know in C++ there's a
that was
pair because I
nice.
used it a little bit. Yeah, so total null. Okay, so then we get rid of this. We get rid of this. Res equals. Get
Both
rid of
solutions are good.
this.
I just was just exploring
No, it's
different
fair. Yeah.
options.
I mean, it's good to like
This
learn these things just to see if there is something better. Like, if there was something pretty clean, then that would. Okay, so now, yeah, get value. Okay, so let's give that a go.
you remove this X node, right? Oh, that's gonna cause issues.
Yeah. Let's see. I'm gonna move this thing so I can actually see. Okay, two errors. Oh yeah, so I'm return calling that guy. And yeah, that's just kind of what I'm spending a lot of time on, just like trying to see if I can write something cleaner. Okay, so this is working. It's 0 now. So I can make like a bigger tree if you want me to, or we can
Just
just see
make a
it working.
slightly bigger tree. Do a add a right child to this guy right here.
Sure.
And just do like 3 and 5. What should that return 0?
I don't think you wrote this correctly, but let's see. 0. Oh, oh, this is the right. Wait. Oh, I see. This is the right child. Yeah, so 0, 3, and 5. 3 and 5. Yeah, it should be 0. And if we try like 0 and 5 or something, then we should get. I mean, they should all get 0. Yeah.
Okay, I'm doing okay. We're gonna slight. This is gonna make this slightly more difficult. But
Okay.
pretend we can have um nodes with the same value.
Uh huh.
How would we solve this question now? Nodes can have the same value.
So
Pretend
going
this
back to
is
the picture, I full screen. I think open a new window. So if we have nodes with the same value, first let's clarify like what we even want here. So let me just toss this. I think you can go here and do DSA or something. Data strip. Yeah. Okay. Did that work or? Yeah. All right. There we go. Nice. So then, so we have this tree. So if nodes can have the same value, like what do we even want, right? Like let's say we have 5 and 3 here, and like 5 and 3 here. Like what are we expected to do? And yeah, like PQ is like
well,
five and
we're gonna be given references. Pretend we're gonna be get reference P in here,
uh huh.
right? We have so what's the like we're
Oh,
gonna
I
be
see. So
given
we're not
references.
looking for values. We're looking for references now.
Yeah, exactly.
Got it. Okay, so in that case, I think the same value doesn't matter at all, and it's kind of the same thing. So instead of comparing by value, we just need to compare by reference. So like, let's say we have all these same things, but like the reference might be like here and here. It's still going to be the same thing, right? Like we just go up the path, and it would be this node. So we have to change
Yeah.
our function where instead of passing like this int, we have to pass down the actual node, and then we have to just compare by reference.
Yeah.
Yeah. Okay. Cool.
Yeah, I'll just modify this real quick. How would we modify this right here though?
Uh. Yeah. So this needs to actually be a node. So maybe we make them first, right? We'll like make this first, and then we do instead of new tree node, we do like p and q or something,
Yeah,
right?
exactly.
So yeah. And so what we have to modify here is instead of this p get val, this has to be like these have to be nodes. And then the rest of it's the same. So if null, so now it's not if node, it's just I think you just do a like if you do an exact equals, it will compare by address. So that would basically solve what we need. And I think the rest of it's the same. So I think this should be fine. Let's see if I missed anything. Yeah. Okay. Cool. We can try something bigger
Oh,
as well. But yeah,
what's that saying? So doesn't it always compare by ref? This is comparing by reference, right? No
it's
P and
comparing by
Q.
address. Yeah.
But that's same thing, right? This is what we
Same
mean
thing, yeah.
by yeah.
Because yeah, like that's what we're looking for, right?
Yeah.
So we're looking for it to be the exact same thing. So yeah, in order to compare by like values, you'd have to make a. I mean, you can make a custom function. You can also override the equals function. Like every
Yeah.
object has an equals, you can just override to say like, oh, in order for it to be equal, don't compare by reference, but do like val equals val or something or whatever you
Yeah.
want.
Yeah. I see.
Yeah,
Okay.
yeah. I mean, I can make it bigger, but it should be the same.
Yeah. Cool. All right. Nice work. Yeah. Nothing really to say. I feel like just this question would take you like 5 minutes on Python, but it just takes way longer on Java. That's the
I
thing,
mean,
huh?
it kind of
So,
depends, right? If you're pushing for things that are hard to do in Java, then yes.
yeah,
But
that's
I
true.
would argue that this solution is not any better than like an array that I was saying
Mm,
earlier, and then I could have done that very quickly. So it's like,
yeah.
yes, if
Yeah.
you're like, I know Java can't do this, but let's do this, then yes, it will take a very long time.
Yeah.
Yeah,
But
yeah.
I feel like even without that, like that was only the last 5 minutes
Uh huh.
that we were doing that. That
Well,
last little bit, the map entry.
you also
Or I
wanted
don't know about
once
that.
again you wanted some specific stuff. Like I couldn't copy a
Yeah,
tree node. Like a lot of times for these problems, I think they just give you the class for free.
that's true.
And
Yeah.
you also wanted like private methods and static, like all the other stuff. So I mean, I could
Yeah.
argue kind of the same thing in Python, right? Like okay, make this tree node, make everything private, and make getters, and you're not allowed to access the variables. Like, is one longer? Like, you have to write the same exact stuff,
Yeah,
right?
that's true.
So,
Yeah.
yeah,
Yeah, I guess just turning to now we know returning tuples is annoying, not
yeah.
really possible, but
Yeah, so you can return a tuple. Like I said, you can make a custom class once I get better at Java. That also doesn't take long. Like I can make a class called pair where the pair will have, like you can literally just do this, like class pair, and then it can have like int val and then like
yeah.
tree node or something. And then you can just return that and initialize it, right? So you could just say like pair val or what's it called? Int val tree node, and then you just do like this val equals val, this node equals node, and then you can basically just return like, or sorry, not return, but you can, instead of returning that tuple or that weird thing, you can just initialize that and return that, and that's not a lot
Yeah.
of code, right? So
That makes
yeah,
sense, yeah. That'd have been fast too, eventually.
yeah, yeah.
Good work. Have good job with the two questions.
Thank you.
Yeah, you know Java pretty good. I
Yeah,
think, oh yeah, well, one thing that Java has too is they actually have the tree map. Do they still have that?
yeah. They
That
definitely have a tree map.
balanced binary search tree.
Yeah.
That
So
was
so
what.
so binary. So that is kind of similar to Python has sorted list. It's pretty rare, but it's also very useful. So sorted list is like it gives you a sorted list for free. So like if you put in items, they'll be sorted, and then you have like log n, lookups, log n, inserts, log in, whatever you want. So it makes a lot of problems like super easy, and if you didn't use it, it would be like way harder. So it's like the same thing. Like I don't know if you've seen that
Cool.
before. There's like a sorted
I didn't
containers.
know.
There's a
I,
sorted
I never
containers in
used a
Python.
I never used a sorted container in Python. I thought back when I was still in school or doing new grads, I straight up would just switch to I would switch to Java if I wanted to do.
That
Yeah.
okay, yeah, yeah. Sorted container has like sorted list, sorted set, sorted dict, but sorted list is like the same as yeah. You just need sorted list basically. So it's like
Is this actually doing a tree map or something underneath? This
sorted
sorted
list?
list?
I think so, yeah. You can look it up. You can just Google
Yeah,
sorted
I'm looking at it.
containers.
I'm
Yeah.
looking at it right now. Let's see.
Yeah. So you just Google sorted containers. And then it has pretty good docs. I think the second one is the one I used, but yeah, this one also shows. So you could do binary search, you could do insert, you could do lookup, you could do remove, like all that stuff. And they're all log n because it's like a under the hood tree.
ChatGPT. Or let's look it up right here. It is
Yeah, for some LeetCode problems, it's definitely like a cheat code.
way
So yeah,
faster, right? Yeah, I
yeah,
never
yeah.
tried this. It's called sorted containers.
Sorted containers, yeah. So you see the top line from sorted containers, import
You gotta
sorted list.
import it though. You have to pip install it.
No, you don't.
Oh, really? The one I'm seeing is pip install.
Well, in I think in
Oh, sorted
LeetCode in
list.
LeetCode you can import. I don't know. Maybe it depends. Like you can try in CoderPad, switch to Python, and try it. I think it probably
Oh, yeah,
depends. Like you might have to pip
okay.
install.
See, this is it's not part of the standard library. That's why I was getting confused. I don't think.
Oh, I see.
It's saying you have to pip install it.
I see.
Cause yeah, I was wondering. I was like, I never knew they had that. Otherwise, I'd never switch. But it looks like
I know in
it,
LeetCode you don't need to pip install because you can just like import it and it works. So maybe it's already imported. I don't know. I don't know what it is in CoderPad.
cool.
So
Nice.
yeah.
Cool. Sick. Good job. Let me know when you want to do more. You're just gonna keep grinding up more Java?
Yeah, yeah, we can do some more. I can get better. Yeah, I think you can also like the nice thing about it is I can come up with some solutions that kind of like you're not used to because like in Python you do it in one way and you might think like oh this way is hard in Java, but it's just because in Java you just have to do it like a different way that was like better for Java. So I'm gonna try to learn more of that. Like
Yeah,
the,
no,
like
that
the
makes
pair
sense.
thing for example. Like if I could make a pair quickly, I could have just done that right instead of doing
Yeah.
this key value hack thing. Yeah.
That makes sense. Like,
Okay.
do you think that in production the array one would be good though, or not really?
No, I don't
Like, you
think
think
so.
the
I
pair
think
one
I
is
think I,
probably
I
the
think I
most
would I
optimal?
think I would make in production. I think you would just make helper things that you use really commonly. Like I know we have like JavaScript didn't have a lot of stuff, so I know we used like Lodash or something. Like I think JavaScript didn't have like built-in map, built-in whatever. So you just make like helper functions that you use all over the place, and then you can just make like a utils or whatever where pair would be one of them. Like you can just make a generic pair where it takes like two values. Yeah, this thing actually on the right, that this class pair kv thing where you could take any kind of except I probably wouldn't call it like kv or whatever, but yeah, something like that. So I think
Nice.
the array thing is kind of hacky in production, but also like when do you have to do this kind of problem in production?
Yeah, you don't have to do this.
I would definitely have a
Even
cleaner solution in production for sure. Yeah.
even one thing that you could do in Python, I don't know if you could do it here, would just defining the public variable.
Yeah, I could have done that. That was the other, but
Is it
that's
easy
also
here
kind of
too, or not
hacky.
really? Yeah.
Like I could have defined the public variable in the solution class and then just reference that. That would work too. Yeah. I think I like the pair the most though, to be honest, out of all of these. Just like make my own pair and use that. That's what I probably would use in production.
Nice. Cool. Yeah. Let me know if you ever have to do that in any other question.
Okay, yeah.
I feel like it's some of them, but yeah. Cool. All right. Let's. Thanks for your coming out
No
for the
problem. Yeah.
interview.
Okay,
Have a
cool.
good night.
Yeah, see ya.
Peace.